Question first. Which congruence criterion do you use in the following figures? From A to D, we have to find congruence criterion. A part, we are given with three sides, namely AC is equal to your DF and AB equals DE, BC equals EF. So we are given all the three sides measures. So you have studied in this exercise that this matches side congruency rule or side criterion of your congruent triangle. That's first. Second, given ZX equals RP, ZX equals RP, RQ equals ZY. This is your RQ equals ZY, two sides and one angle, that is angle R and angle Z, angle R and angle Z. And if you observe that this angle falls within these two given sides, that is RP and RQ or ZX and ZY. So it follows side, angle, side, side, angle, side. Congruency rule or congruency criterion. That is your B part. C, given angle L and G, L and G is given, and M and F is also given. M and F is also given. Also one side is given, ML equal FG. ML equal FG. So in this case, we are given this angle L that matches with angle G, M matches with F. So we can mark it with two angles. That is M matches with your F. It is your F. And also one side, that is ML and FG. So note that this side falls between these two angles. Then only we can apply angle side angle criterion. Therefore this follows angle side angle criterion in order to make triangle LMN congruent to triangle GFH. D, we are given with side EB equals DB. EB equals DB. This is represented by this one dash. Then we are given AE equal BC. Again this side equal BC, therefore marked with two parallel lines. This means that AE equals BC, and we are given with one right angle. This represents right angle, this square box. It is very easy. We get RHS congruence rule. What is RHS congruence rule or criterion? Its elaborated form is right hypotenuse side. Right angled, this is your right angled hypotenuse, that is opposite to this right angle, and one side is given. That must correspond to other side. So here also right angle, one side is given which corresponds to this, and another side is given, that is BC, which is equal to AE. Therefore it follows right hypotenuse side criterion. That is your D, and that's your first. Question second. You want to show that triangle ART, this is your triangle ART, it is congruent to triangle PEN, that's PEN, by using following criteria from A to C. In A part, we have to show that triangle ART is congruent to triangle PEN using side criterion. And what does it mean? It means that we have to show that all the three sides are equal in both triangles. First one is AR side, it corresponds to PE. Therefore we wrote PE. And RT, we have RT that corresponds to EN. You cannot also write as NE. That will be wrong because correspondence or relation plays a vital role in congruence of triangles. Third is AT, side AT. So we have to select first P that corresponds to A, and then T, here P with N because N corresponds to T. You can also do it from the relationship itself. For instance, AR, similarly we will check the pattern PE, then second was RT, that means EN, and then AT, first and third, AT, so first and third, EN. So that is your A part. Now we have to prove the same thing using side angle side criterion, and one angle is given, that is angle T equals angle N. That means this angle equals this angle. Now what are the conditions for side angle side? That is, there must be two sides given, that is measure of two sides must be given, and the corresponding angle between those two sides. This means we are given with this angle. Therefore, this side and this side must be given to us. That must be corresponding to this side and this side. The same we are doing here. So RT, one of the side is RT, it must correspond to EN, and that measure should be given to us in order to prove it by side angle side criterion. So therefore EN. Second is PN. This is your PN. So corresponding to it is side AT. Therefore we wrote AT. That's B. Now we have to prove with angle side angle. Again, when we prove using angle side angle, there are two angles given, and between them one side has to be given to us. And that is given to us. AT equals PN. AT equals PN. Now, what are missing parts? Angles, which touches these both line segments. That is angle P and angle N must be given. So therefore angle RAT, this is your RAT. So this must correspond to what? P, or you can say angle EPN. So therefore angle EPN is your answer. And second angle must be this one or this one. That is angle ATR must correspond to what? PNP. You can also name it as RTA correspond to ENP. Then you cannot write as PNP. Although they are same, but you have to again keep the relationship intact. So that is your C of question number 2nd. Question 3rd. You have to show that triangle AMP, this is your triangle AMP, is congruent to triangle AMQ. AMQ. In the following proof, supply the missing reasons. So we have to provide reasons for the following. In this question, we are given with the steps and we have to find associated reasons for each step. So first is PM equals QM, and we have to show that, or we have to prove that triangle AMP, this is a triangle AMP, it is congruent to triangle AMQ. So here are the steps. We will provide reasons for these steps. So first is PM equals QM. PM equals QM. Why is it so? Because it is given by two parallel lines that this line segment is equal to this line segment. That is given to us. So first one is given. And second, angle PMA equals angle QMA. Here is your angle PMA equals angle QMA. Again it is given, represented by two arcs. This is given to us. That is given means it is given, this information is provided to us in the question itself or in the figure itself. Now AM equals AM. AM equal AM. Well, it is not given to us, it is common. This means that side AM or line segment AM is common to both triangle AMP and AMQ. Therefore, we write common side or common symbol. And last, therefore, we can conclude that triangle AMP equal AMQ by side angle side criteria. Because we know one of the criterion in order to prove the two triangles are congruent is side angle side. That is, we are given this side that corresponds to this side, we are given this angle, and we found this side as common. Therefore, side angle side, side angle side. Therefore, these both triangles are congruent to each other through SAS criterion. So that is your question number 3rd. Question 4th. In triangle ABC, angle A measures 30 degree, B 40 degree, and C 110 degrees. In triangle PQR, P 30 degrees, Q 40 degrees, and angle R measures 110 degrees. Now, a student says that triangle ABC is congruent to PQR by angle, angle, angle. Is he justified? Why or why not? As you have learnt in this chapter that there is no AAA congruency rule or angle, angle, angle criterion in order to prove that two triangles are congruent to each other. This says two triangles with equal corresponding angles need not to be congruent. That is, they may be or they may not. In such a correspondence, one of them can be enlarged copy of the other. As we have shown here, they would be congruent only if they are exact copies of one another. So what was happening in the question that we have two triangles, namely triangle ABC and triangle PQR. Both had same angles. Both had same corresponding angles. Angle A was 30, angle P was 30. So 30, 30, AB. Angle B and angle Q. Angle B and angle Q were 40 degrees. and angle C and R. Angle C and R is 110 degrees. But if you try to place this angle on this angle, this triangle will not cover this triangle. And what does congruent triangles mean? That means they will cover each other completely without leaving nothing extra space. But here it fails. So it proves that there is no criteria such as angle, angle, angle in order to show that two triangles are congruent to each other. That is, if we are provided with all the three angles and no side is provided to us, we cannot come to the conclusion that both triangles are congruent. It may be if they are exact copies, as the statement says, if they are exact copies of each other. But in case of enlarged copies, they are never congruent to each other. So a student says that triangle ABC is congruent to angle PQR by using angle, angle, angle criterion, which doesn't exist. So is he justified? Well, no, because we have told the reason. So this is your fourth question. Question fifth. In the figure, the two triangles are congruent. The corresponding parts are marked. We can write triangle RAT is congruent to what? In this question, we are provided with two triangles which are congruent. It is given to us that two triangles are congruent. So we have to show the corresponding parts of triangle RAT to what in this triangle. So we will try to deduce the same. Here, if you see that angle RAT, that is angle RAT, is equal to which angle here? This one, because this is represented by two arcs. Two arcs. It means A is equal to O. And the reason is given. Therefore, we wrote given as we did in previous question. Another angle that you can see here common is this one, angle R. Or you can say angle ART is equal to angle OWN, because represented with single arc. So far, we have found two angles. Two angles are given, and also one side is given, which is in between these both angles, that is AR and OW. So this falls on the given angles, that is angle W and O, and here angle A and R. So you can come to the conclusion that these both triangles are congruent by using angle side angle criterion, that is angle side angle, or you can also say angle side angle. And this was your given reason, and this is the deduced argument. We can also come to the same conclusion, that is angle RAT is congruent to angle WON using SAS, that is side angle side. How? Well, if you see here, AT is equal to what? QN, this side. Then you have this angle here, same, and this side, same. So you can also come to this conclusion by using side angle side, that is side angle side. So there are many ways by which you can prove a particular relationship of congruency in triangles. You go with what you see first. So that is your question number 5th. Question 6th. Complete the congruence statement. Triangle BC is congruent to what? And triangle QRS is congruent to what? Again, in this question, we have to find the congruency relationship. First case is triangle BC is congruent to which triangle here? Well, if you observe these both triangles, that is triangle BCA and BTA, you observe that this side is common to both of them, this side is given, and this side is also given equal. Well, you can establish side, 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 and you can prove that this triangle is congruent to triangle BTA by using side, side, side criterion. Again, you can prove it using angle, side, angle. Here, this angle equals this angle, this side is common, and this angle equals this angle. This is 90 because 180 minus 90, linear pair. So you also prove it using angle, side, angle. Again, you can also prove this relationship using side, angle, side. This side is common, this angle is common, this side is equal. Therefore, by using side, angle, side. And another one interesting criterion is RHS, or right hypotenuse side. This is your right angle. Hypotenuse is opposite to your right angle, and one side is corresponding to one side here as well. This is 90 degree. This is equal. Hypotenuse is equal, and one side is equal, which is corresponding as well. So this can also be proved with right hypotenuse side, or RHS. Now, the second figure, triangle QRS. PQRS is congruent to what? Well, if you observe here, this side is equal to this side, and this angle equals this angle. P equals angle R. What does it mean? It means this angle S and this angle Q, internal angle, which is represented with dots, will be equal. The sum of all the three sides equal to what? 180 degrees. So first, by using side, because all the three sides are given to us, we can deduce the relationship as triangle TPQ and how we came to this conclusion. So you can start from angles. So this is one, this is second, this is third. So T, P, Q. So what is first here? This is first here. That is Q. What is second here? R. And third S. So QRS. In this way, you will never be wrong. Therefore, you can conclude that triangle QRS is congruent to triangle TPQ using side criterion. Similarly, this can also be proved using angle side angle. This is your angle which corresponds to Q. Then there is a side which is equal to this side. There is again an angle which equals this. So therefore angle side angle. And lastly, it can also be deduced using side angle side. This side with this angle with this, and this side with this. Therefore, as we mentioned earlier, there are many ways to show congruency. You just pick whichever you see first or whichever you find with ease. So that is your question number 6th. Question 7th. In a squared sheet, draw two triangles of equal areas such that, number first, the triangles are congruent. Second, the triangles are not congruent. What can you say about their parameters? Here we are with a squared sheet and we have drawn 4 triangles where we will try to solve 2 different parts of this question. So first part is the triangles are congruent. So you can see here we have drawn exact copies of this right angle triangle. You can take any triangle, just keep in mind that they both must be congruent. That is, their size and their shape must be same so that they can cover each other. While using squared sheet, it becomes a very easy task to construct congruent triangles. So assume this distance is of 1 centimeter. So it is 1, 2, 3, 4 centimeter base. Again 1, 2, 3, 4 centimeter base. Height is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This side will be equal to this side. We can construct it using 3 parallel lines. This is by 1, so this should be by 1 also. And this is hypotenuse. This is also equal. Now if you count the perimeter, that is the boundary of this triangle, so 5, 5, and if you count this also by square rooting using your Pythagoras property, you will find that both have same perimeter. And we can come to the conclusion that whenever 2 triangles will be congruent to each other, their perimeter will always be same if their areas are same as well. And the second part was we have to construct 2 triangles which are not congruent but they have same area. So if you observe here, this triangle and this triangle are having equal areas. Mathematically, you will find some formulas in later classes which will prove that they have equal areas, but for now you can count these boxes. These boxes will be equal to these boxes. And how to count them, you have learned in your previous class. That is, take 1 centimeter square for a complete box, and for this take half. That means this both will make 1. Similarly, you can count them, they will come exactly same. That means their areas are same, but they are not congruent. Why? Because this is 90 degree and you cannot see any 90 degrees here. In first condition, it fails, that these are not congruent. And when you try to find the perimeter on your notebook, when you measure it using your scale, these both triangles, their perimeter will not be same. So that is what this question was asking for. That is, if we have 2 triangles who have same area but they are not congruent, their perimeter will not be same. So that is your question number 7th. Question 8th. Draw a rough sketch of 2 triangles such that they have 5 pairs of congruent parts, but still the triangles are not congruent. In this question, we are asked to find 5 pairs of congruent parts. That is, 5 parts are equal or congruent to 5 parts of another triangle. So we have taken 2 triangles, namely ABC, and another triangle PQR. We have shown that angle A measures angle P, B measures Q and C measures R. Also, we have two sides which are equal. AB measures PR 12 cm and AC measures QR 18 cm, but one side doesn't match. That is, BC doesn't match PQ. So we cannot come to the conclusion merely by using angle criteria. This we have studied. Why? Because they are not exact copies. That is, their sides are different. So we cannot come to the conclusion that both triangles are congruent to each other. In this way, you can show that there are triangles which have 5 congruency relationships, but their one congruency fails. So that we cannot come to the conclusion that both triangles ABC is congruent to PQR. And that is what this question was asking for. That is your 8th. Question 9th. If triangle ABC and triangle PQR to be congruent, name one additional pair of corresponding parts. What criterion did you use? In this question, we are given that if triangle ABC and PQR has to be congruent, then what is the missing criteria in these both triangles? Well, let's check what is given to us first of all. Here, if you check B equals Q, that is 90 degrees, and one angle is given, that is C is equal to angle R. So whenever you see two angles are given to you, so right away you have to see if whether the side between those two angles is given to you. Well, in this case that is not given. It also asks for that one condition, that is one additional pair that will prove this relationship, that is triangle ABC congruent to triangle PQR. So if we come to know this side measure, that is measure of side BC or line segment BC, and that must correspond equally to QR, that is BC equals QR, then we can deduce the relationship as angle side angle, that is angle side angle. So BC must be congruent or equal to QR. If we have this one additional pair, then we can conclude this, that is triangle ABC is congruent to triangle PQR by using angle side angle criterion. So that is your question number 9th. Question 10th. Explain why triangle ABC is congruent to triangle FED. This is your triangle ABC and we have to explain why it is congruent to triangle FED. In this question, we have to prove or we have to explain by giving reasons that triangle ABC, this is your triangle ABC, it is congruent to triangle FED. So let's give the reasons for the same. First of all, whatever is given to you. Given means whenever the information is provided to you in the figure itself, that is by the question itself. For that we write given. Angle A measures F because represented by two arcs, therefore given, already provided. Then angle B equals E. This square box, again it means 90 degrees. It is given to us also 90 degrees. And there's one side also given that connects from 90 to this angle, that is represented with dot. In this case corresponding as 90 degrees towards this dot. This side is equal, therefore BC equals ED, not as DE. In congruency, pattern or relation plays important role. Given. Now if we observe in this figure, whenever you see right angle triangle and you have to prove congruency with other triangle, first of all, always go for RHS, that is right hypotenuse side. Well, we have right angles D and E, we have hypotenuse, but its length is not given to us. So we cannot apply RHS here. We have to find some other criterion for that. Well, we have one angle, we have one side, but we don't have another angle, so that we can apply angle side angle criterion. But when we observe the figure, we have two angles given to us and they are corresponding, that is B correspond to E, F correspond to A. We can find a third angle, it is very well known, that is 180 minus these two angles when subtracted from 180, because all the three angles measures equal to 180 degree. Therefore, this angle C that is represented with red dot will be equal to angle T, because both the angles are same. Therefore, angle C will be equal to angle T, because sum of the three angles measures 180 degrees. Therefore, this is the reason. Now, since we know that this angle is given, this is also given, this we deduced. So angle side angle or angle side angle. By this property, we can deduce that triangle ABC is congruent to triangle FED by using angle side angle criterion. By congruent, we mean this sign. So in this way, you look at the figure and you try to find the criteria that fits into the figure and prove whether they are congruent or not. So that is the last question, question number 10.